All right, section 10.2 talks about displaying data, part one. So we're going to have something called data. It says data can be categorical, numerical, or ordinal. And it says data collected may be categorical, numerical, or ordinal depending on the questions being answered. Categorical data are data that is represented or that represents characteristics of objects or individuals in groups or categories, such as black or white, inside or outside. It might be the case that on a form, a person could be asked to check one if yes and two if no. Even though these checks are numbers, the number has no mathematical meaning. They could not be added or subtracted in a meaningful way. Numerical data are data that's collected on numerical variables. For example, in grade school, students may ask about the distance that can be jumped. The distance is a numerical variable, and the collected data is numerical. Ordinal data combine numerical and categorical. Data may fit into categories, but the numbers placed on the categories have meaning. For example, a candidate on a scale from 0 to which is the lowest to 5, which is the highest, gives an ordinal data. These data are sometimes treated like categorical when graphs and charts are made. However, unlike most numbers in categorical data, these numbers have mathematical meaning. For example, if you survey 50 people to rate a candidate on a scale from 0 to 5, an average score of their responses has meaning. With true categorical data, this is not the case. Okay, so we're talking a little bit about pictographs. So it says an elementary student might use a pictograph to represent tallies of categories of their favorite pets. Categorical data are seen in the pictograph on schoolbook page 586, where the dog is a type of category. Let's see. It says a legend tells what the symbol represents. Pictographs are used frequently to show comparisons of quantities among different categories. A major disadvantage of pictographs is evident in figure 2. The month of September contains a partial bundle of newspapers. It is impossible to tell from the graph the weight of the partial bundle with accuracy. So they're referring to this part right here, okay? All right. So let's take a look. It says the number of the students and teachers in each teacher's 5th grade class at Hillview School is depicted in the tabular representation in Table 2. Each teacher is a category, and the frequency or count table provides a method to summarize the categorical data in Figure 3, depicts the information in a pictograph. All graph needs titles, and if applicable, legends should be shown. So here we have the number of students in each teacher's 5th grade Hillview School. So teacher Aim has 20, teacher Ball has 20, Cox has 15, Day has 25, Eves has 15, Fagan has 10. Okay, and so they made a pictograph right here, and they're telling us that each little person represents 5 students, right? Okay, so let's go ahead and take a look at our first problem here. It says make a pictograph to represent the categorical data in the table to the right. It's actually below. And use a little glass to represent 10 glasses of lemonade sold. Okay, so we're going to go ahead and do this part now. All right, so let's do it this way. So we're going to make a pictograph, and we'll talk about, oops, get my pen working again. Glasses of lemonade. Okay, and so it looks like we have the days of the week, Monday through Friday. Okay, so, oops, I went a little too far. Let's do this. Monday, Tuesday, Wednesday, Thursday, Friday. And remember, one little glass represents 10 glasses sold, okay? So here we'll say these are going to be the days of the week, obviously, right? And here we'll say number of glasses, okay? And so I kind of make like a little chart of sorts if I can. Okay, So Monday we sold, oops, let me scroll up a little bit. There we go. Okay, Monday we sold 10 glasses, so Monday we'll have a glass. Tuesday we sold 2, so 1, 2. We sold 20, right? Wednesday we sold 15 glasses, so I'm going to put a full glass, and then I can do, say, half a glass, right? Let's see. Thursday we sold 25, so I'm going to put 2 full glasses, and then maybe a half glass. And then Friday we only sold 5 glasses of lemonade, so my glass will look like that. And here's my pictograph, okay? So my picture obviously is a little messy, guys, because I'm doing this freehand, but obviously these are supposed to be half glasses, okay? Alrighty. So we have something called dot plots, sometimes called them line plots. It says, next we're going to examine a dot plot or a line plot. Dot plots provide a quick, simple way of organizing data. Typically we use them when there is only one group of data with fewer than 50 values, okay? One minor difference in dot plots and line plots is that a line plot almost always uses a number line as a base, while a dot plot may not. It says, suppose 30 students in Abel's class receive the following test scores. A dot plot for the class scores consists of a horizontal number line on which each score is denoted by a dot or an X above the corresponding number line value, as shown in figure 5. So here is our picture. So it says several features about the data become more obvious when dot plots are used. Figure 5 yields information about Abel's class exam scores. 3 students scored a 76. 4 scored greater than a 90. The lowest score was a 52, and the highest score was a 98. Outliers, clusters, and gaps are apparent in a dot plot. An outlier is a data point whose value is significantly greater or less than the other values, such as a score of 52. We'll be talking about outliers a little bit more. And it says a cluster is a group of points, such as the ones located around 97 and 98. Let's see. A gap is a large space, such as the ones between 88 and 97. Okay. All right. So it says another feature of the data is the score that appears most often in a data set. It appears at 82. Why 82? Because here would be 82. Let me get my pen going again. Sometimes it freezes. There we go. So here's 82. You can see that's the highest one. So that's going to be the mode, not the highest value, but the score that occurred the most often. Okay. So it says dot plots can be used to compare populations. Let's see. So here is some information that we have. And it says 6th grade students reported the number of apps that they downloaded to their smartphones. Construct a dot plot from the results given to the right. Okay, so first thing I'm going to do, I'm going to draw a horizontal line, okay? And it looks like the smallest value we have is 0. It looks like the biggest value we have looks like to be 25. So I'm going to go in 5. So 0, 5, 10, 15, 20, 25, right? Okay, and then what I'm going to do is we're going to count the number of zeros, okay? So we have 1, 2, 3, 4, 5, 6, 7. So I'm going to go 1, 2, 3, 4, 5, 6, 7, okay? And then I'm going to make smaller lines. So I'm going to go like this, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. There we go. Okay, so now let's do the ones. It looks like there's only one. Okay. Any twos? Yes, there's a 2 right here. Okay. Any 3s? No. Any 4s? No. Any 5s? It looks like there's 1 5. Okay. Any 6s? Yes, I have 1 6. Any 7s? No. Any 8s? Yes, we have 1 2. 2 8s, so that's 6, 7, 8, two of them. Any 9s? Yes, we have a 9 right here. Any 10s? Yes, we have two of them. Okay. Any 11s? Yes, it looks like we have 1, 2 11s. 1, 2. Any 12s? Yes, I see 1 and 2 and 3. So 1 and 2 and 3. Okay. Any 13s? No, but I do see a 14. 1 15. Okay. Any 16s? No, I do see a 17 right here. So 17 right there. And it looks like the next one that we have, because we've scratched out all the numbers, is 25, right? So one thing we could say is, when we look at this thing here, it's just asking me to make the dot plot, right? Which we did. But a couple things we observe. There's gaps here, right? Because there's a gap right there. It looks like we have a cluster between 8 and maybe 11 right here. That's a cluster. It looks like 0 is the mode, which would mean that most people have no apps on their phone, right? And then we might say that 25 is an outlier. That's 1 6th grader who has a whole lot of apps on their phone, right? Okay. Let's see. Okay, so here's a dot plot, and it says the midterm test scores for 7th grade period typing class are shown in the dot plot below. What is the most frequent score? So when they're asking me for the most frequent score, y'all, we're looking for the mode. The mode is the one that recurs the most often, which would be the highest little, series of X's here. And it looks like 89 would be my mode, right? That's the highest one. All right. Excuse me. So now we're going to talk a little bit about stem and leaf plots. It says a stem and leaf plot is akin to a dot plot. The scale is usually vertical, and digits are used rather than X's. A stem and leaf plot of test scores for Abel's class is shown in Figure 7. The numbers on the left side of the vertical segment are the stems. The numbers on the right side are what we call the leaves. And it says the stems are the 10 digits from the scores on the test, and the leaves are the units digits. So it says right here, the legend 9/7 means a 97. Okay, so let's talk about this a little bit. If I look at this stem and leaf plot here, what this means that there was a grade of a 52. That looks like the lowest grade. There were no grades in the 60s. There was a 70. If you notice the number 2 appears twice, that just means that there were 2 72s. Okay? And then there was a 73. There was a 75. It looks like there were 3 76s. A 77, a 78, and then the same thing we do the same thing for the 80s and the 90s and stuff like that, right? So we would say, okay, well, a couple of things we could observe. We could say, well, the lowest is a 52. We could say, well, the highest grade would have been a 98, right? That looks like the highest grade. If I were to say, what is the mode? What grade was the most common? I might look here and say, it looks like an 82 would have been the mode, right? That's the one that occurred the most. Okay, so it looks like we had 4 82s. All right. All right. So we're going to do some stem and leaf plots here, and it says the data below shows the number of car thefts in a city for a period of 20 days. Complete parts A and B below. So the first part says draw an ordered stem and leaf plot for the data. Okay, so the way we're going to do that is we're going to put a vertical line, okay? And we're going to start with our smallest values first, okay? So it looks like the smallest value we have is a 35. So I'm going to put a 3 here and a 5 here, and that just means that there's a 35, okay? And I don't see that I have any other 30s, so I'm going to go ahead and scratch that one out. And then we're going to start looking at the 40s. So I see this one here and this one here. And I think those are the only 40s that we have. And we have 47. So I'm going to go like this, 47. And because there's two of them, I'm going to write the 7 twice. Okay. And then I'm going to start looking at the 50s. So I have a 51, another 51, another 51. Okay, so I'm going to go like this. 51, 2, 3, because we had 3 of them. Okay. And we still have some other 50s. The next one would be a 54. So I'm going to put a 4 over here. And then we have a 57 right there. Okay. And I think those are all the 50s. So then I'm going to start going to the 60s. And it looks like the smallest one in the 60s we have would be a 64. So I'm going to put a 4 right here. That's a 64. We got a 65 over here. Okay. And we have 1 and 2 67s. So 1, 2 67s. And I think those are all the 60s. Oh, we got one more, 68 over here. Don't forget that one. Okay. And let's see. Now we're going to start going to the 70s, okay? So in terms of the 70s, the 70 is the smallest one, okay? And then it looks like we have a 74. And it looks like we have 277. Oh, you know what? I forgot a 53, didn't I? Okay, we'll go back and fix that right now. 77, 77. And we have a 78. Oops, 78, not 70, not an extra 77, but a 78. Okay. And I said I was going to come back and fix this 53. So let's do that right there. Okay, we got it. And then we have an 80. Okay. So one thing we always have to do, guys, when we make our stem and leaf plot, we have to make what they call a key or a legend or something like that. So I might just do something like this. 5-3 means 53. Okay. All right. So we answered the first part. We drew our stem and leaf plot. It's right here. Okay. Now, part B says, what percent of the 20 days had more than 70 cars stolen? More than 70 cars. So not 70 cars, but more than 70 cars. So look, let's count that are more than 70. 1, 2, 3, 4, 5. 5 out of 20. Okay. 5 out of 20, if I divide them both by 5, would be 1/4. And because it's asking me for a percent, I'm going to go ahead and get my calculator going. Let me turn it on. Let me clear it. 5 divided by 20, or I could do 1 divided by 4. Either way, I'm coming up with 0.25. Okay. So as a decimal, this is 0.25. And if I want to convert that to a percent, you may remember this. And if you don't, I'm going to show you right now. You're going to move your decimal point 2 spaces to the right, and we'd have 25%. Okay. All right. So the next part here says, the weights in pounds of a group of high school students are listed in the stem and leaf plot to the right. What is the most frequent weight? Okay, so again, we're looking for the number that occurs the most often. So when it says the most frequent weight, we're looking for the number that occurs the most often, which is what we call the mode. Okay. All right. So I may not have put the key here, but just to give you an idea, what does this mean? Like 15/1 means 151 pounds. Okay. All right. So looking at this here, the number that appears to occur the most often would be that right there, which would tell me 142 pounds. Okay. All right. So in addition to stem and leaf plots, guys, we often look at, bar graphs and double bar graphs. This here is a double bar graph. And it says the double bar graph below shows the number of male and female athletes at a university over a 4-year period. Which year had the greatest number of male athletes? So I'm going to look at the male, which is the blue bar, see what year is the highest. And it looks like in 1989. That's an old graph, isn't it? Okay. And we also have pie graphs here. So let's take a look, see if we can figure out pie graphs. It says the circle graph below shows the percent of total population of 44,000 of a city living in the given types of housing. Find the number of people who live in condos and then round our answer to the nearest whole number. Okay, so the first thing we're going to do is we say, how many people are living in this city? 44,000, okay? We want to know what percent of them live in condos. Condos is 20%. So we're going to multiply this by 0.20, okay? Because as a percent, if it's 20%, remember to go to a decimal. If I don't see it, it's right there. I'm going to move it 2 spaces to the left, and now it would have 0.20. So let me grab my calculator again. 44,000, 123, times 0.20. And it told me to round to the nearest whole number. Okay, we already at the roundest nearest whole number, 8,800, right? 8,800. So 8,800 folks live in condos. Okay. Let's take a look here. In a school survey, students showed these preferences for instructional materials. The results are shown in a circle graph on the right. About how many students would you expect to prefer computers in a school of 700 students? Okay, so computers is 36%, and it's telling me that the number of students we're looking at is 700. So we're going to multiply that by 0.36. Okay, so let's go 700 times 0.36, and I'm coming up with 252. Okay, oops, 252. Okay. And that right there, guys, was 10.2.